Okay, so Stefan tosses 2 coins and Rewa also tosses 2 coins. What's the probability that both of them get at least 1 head? So probably the best thing here is to draw a tree diagram representing, well, one of them anyway, and then you can work things out from there. So if we just get the right color pen here. So starting from here, so there's 2 options. When, let's just say this is Stefan, heads and tails, and of course, being a fair die, we would assume that they're both a half in terms of probability. And for the second throw of the dice, again, we've got heads and tails, and again, we'll put the probabilities on. They're all equal to a half. And we know that half times a half, so half equals 1/4. Half tails equals 1/4. Tails half, head, sorry, equals 1/4. That's a half times a half. Just write that up here. 1/2 times 1/2 equals 1/4. And then tails equals 1/4. And the ones we're really interested in are these ones here because they meet the criteria of at least 1 head. So the probability that Stefan gets at least 1 head is equal to 3/4. And Rewa are doing the same thing. So the probability that Rewa is also going to get 3/4 because it's exactly the same process. So then it says, what's the probability Rewa get at least 1 head? Now, the 2 of them tossing coins is independent. So this example is independent because what Stefan gets is independent of Rewa. Therefore, the equation for this is that the probability of A intersection B is equal to the probability of A times the probability of B. So in this case here, the probability of Stefan and Rewa, so it's an and, that they both get at least 1 head is equal to the probability of A, which is 3/4. That's the probability that Stefan gets at least 1 head, times the probability that Rewa gets at least 1 head, which is also 3/4. And of course, that all comes out that 3/4 times 3/4 is equal to 9/16, which is the same as 0.5625. And that's your answer for that one.